All right, welcome back. This lesson is called Infinite Geometric Series, and the question today is, can you add forever and get a value? Can you add forever and get a value? And the answer to this question is yes, you can add forever and get a value. Or what we say, you can add forever and converge to or get very close to a number. Watch this. So before we get started, we have to get these down in our notes. 1 over 9, 1 over 9. 1 over 9 is 0.11111111111. 1 repeating forever. Let's see, 2 ninths. 2 ninths is 0.22222222222 or 0.2 repeating forever. 3 ninths, this never stops. 3 ninths is 0.3 repeating forever. You know this because 3 ninths is a third. You know that the 1/3 is 0.3 repeating forever. 0.3333333 forever. 4 ninths. 4 ninths is what? 0.4 repeating forever. 5 ninths. 5 ninths is what? 0.5 repeating forever. 6 ninths. 6 ninths is 0.6 repeating forever. 7 ninths is 0.7 repeating forever. 8 ninths is 0.8 repeating forever. Okay, so we have 0.6 repeating forever, 0.7 repeating forever, 0.8 repeating forever. What's 9 ninths? What's 9 ninths? 9 ninths is 0.9 repeating forever. Or is it? Okay, that's the question. Is 9 ninths, because you are always told that 9 ninths is 1. Okay, so is 9 ninths 1 or is 9 ninths 0.9 repeating forever? This is the question we have to answer today. Is 1, 9 ninths you've been told is 1. The question is this. Is 1 equal to 0.9 repeating forever? Now there's some interesting things here to note. I want you to notice something. I want you to write this. Now 0.1 repeating forever, I want you to write as 0.11 repeating forever. 0.2 repeating forever, write it as 0.22, 0.33, 0.44. So write this, 0.44, 0.55, 0.66, 0.77. You don't need to do this. You don't need to do this when writing a repeating decimal. What I want you to do this to see a pattern. So go ahead and write this. Now, 1/11th. 1/11th. 1/11th is 0.09090909090909 forever. So 0.09 repeating. 2/11ths is 0.18181818. 0.18 repeating forever. 3/11ths is 0.27272727 or 0.27 repeating forever. 4/11ths. 4/11ths is 0.36363636 repeating forever. I want you to notice something. There's a relationship between the ninths and the 11ths. A relationship between the ninths and the 11ths. See if you can find it. Notice. My question is, what is 1 times 11? We're in the ninths over here. What is 1 times 11? 1 times 11 is 11. What's 2 times 11? 2 times 11 is 22. 3 times 11. 3 times 11 is 33. 4 times 11 is 44. 5 times 11 is 55. That's interesting. Now look over here. Same thing. Okay, so with the ninths, you multiply by 11 to get your decimal. With the 11ths, you multiply by 9. Look at this. 1 times 9 is what? 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. There it is. So we see a pattern here. 5/11ths is what? 5/11ths is 0.45 repeating forever. 6/11ths is 0.54 repeating forever. 7/11ths is 0.63 repeating forever. 8/11ths is 0.72 repeating forever. Think of 8 times 9 is 72. 9/11ths is 0.81 repeating forever. 0.8181818181. 10/11ths. 10/11ths is 0.90 repeating forever. Now notice the pattern here. 36. Let's see. 54 plus 9 is 63. Plus 9 is 72. Plus 9 is 81. Plus 9 is 90. Plus 9 is what? 99. So 0.9 repeating forever is what? 11/11ths. Or the question is this true or is this false? The answer to this question is yes. Okay, and I'm going to show you why this is the case. Is 1 equal to 0.9 repeating? The answer is yes. Well, let me say it like this. Right now, the answer is no. Okay, so entering into this lesson, I should say this. This gets confusing. Okay, so right now, the answer is no. But by the end of the lesson, the answer will be yes. So right now, is 1 equal to 0.9 repeating? No. But by the end of the lesson, is 1 equal to 0.9 repeating? Yes. Now, we're going to look at, where's my eraser? Okay, so we're looking at here, concepts of forever. Okay, concepts of forever are not easy to grasp. In fact, our minds will never be able to understand this. But first off, let's look at the tortoise and the hare question. Okay, the tortoise and the hare. The tortoise takes off. The tortoise has been traveling for a while now. Okay, so this is the location of the tortoise. Here's our tortoise. I can't draw. But let's see if we can kind of get an idea of, here's the tortoise. The tortoise has been moving. Okay, so the tortoise has been moving for quite a while now. So the tortoise has maintained a distance. Now, the hare is going to take off. The question is, will the hare ever catch the tortoise? Will the hare ever catch the tortoise? A famous philosopher, either Aristotle or Plato, one of these guys thought of this back in the day. And the question was, will the hare ever catch the tortoise? Now, I can't draw a hare, so we're just going to do this. Okay, that's a hare. Okay, it's a hair on your head. Okay, so this is a hare. Okay, so since I can't draw it, this is better. Okay, so the question is the hare ever going to catch the tortoise? Let's see here. Okay, so in time, okay, so the hare is going to take off. The hare takes off, and what happens? The hare gets halfway closer to the tortoise. So the hare takes off, right? And what happens? The hare gets halfway to the tortoise, and what happens? As the hare is moving, the tortoise is also moving. So the hare gets halfway closer to the tortoise. Has the tortoise moved in this amount of time? Yes. Now, the hare gets halfway closer to the tortoise again. So in the next moment of time, the hare gets halfway closer to the tortoise again. Now, in this moment of time, has the tortoise moved? Yes. The tortoise has moved. Now, in the next length of time, the hare gets halfway closer to the tortoise again. The hare gets halfway closer to the tortoise again. During this length of time, did the tortoise move? Yes. Okay, the hare gets halfway closer to the tortoise again. During this length of time, did the tortoise move? Yes, just a little bit, but he moved. Okay, so the hare gets halfway to the tortoise again. He gets halfway closer again. What happens? The tortoise moves. Okay, the hare gets halfway closer again, and what happens? The tortoise moves. So as every time the hare gets halfway closer, what happens? The tortoise moves away. Halfway closer, the tortoise moves away. So is the hare ever going to reach the tortoise? Is the hare ever going to reach the tortoise? Theoretically is what I'm saying. So there's a difference between the theoretical and what actually happens. So is the hare ever going to reach the tortoise? You say no. Theoretically, no. The hare will never reach the tortoise. But the answer is, what happens out there in real life? What do we observe with our eyes? With our eyes we observe, yes, the hare catches the tortoise. In fact, in real life, the hare not only catches the tortoise, but the hare passes the tortoise. So, in real life, do we ever get there? Yeah, the hare gets there and passes the tortoise, but theoretically, thinking, will the hare ever get to the tortoise? No. In terms of half distance, forever the hare will get close. But every time the hare gets halfway closer, the tortoise moves slightly further away. Halfway closer, the tortoise moves slightly further away. So these are concepts. Now, another question is here. Is my hand touching the wall? No. There's nothing but a bunch of empty space between my hand and this wall. Why? Because at the atomic level, thinking in terms of atoms, okay, so if this pen represents the nucleus, or this marker represents the nucleus of the atom, where are the electrons? The electrons are way out there, a mile away, spinning around this thing. And they're micro small, the size of grains of sand, spinning around this thing. What's between the nucleus of the atom and the electrons way out there? Nothing but empty space, nothingness. And I am made up. My body is made up of atoms. So what am I? I'm nothing but a bunch of empty space. There's nothing here. But in real life, what do you see? You see something. Okay, but what am I theoretically? Nothing but just a bunch of empty space. In fact, at the atomic level, this is true. Nothing that you see is everything you see, I should say. Everything you see is nothing but a bunch of empty space. Yet we see something and we feel something. Okay, so the concept of forever getting close and never getting there. 0.999999999 is this one. The mind cannot fathom concepts of infinity. So let's ask ourselves, watch this. This is very interesting. So I've written up here, we're studying infinite geometric series. Remember, geometric means something is being multiplied. I've written the sum here, 16 plus 8 plus 4 plus 2 plus 1. Let's look at this. Okay, so we're asking here, 16 plus 8 plus 4 plus 2 plus 1 plus the ... means we're adding what? ... means we're adding forever. My question is this a number? Okay, so we have to ask what's happening here. What's happening to go from 16 to 8? You say, well, dividing by 2. Well, let me remind you guys of something. Dividing by 2. Dividing by 2 is the same as what? Dividing by 2, division changes to what? Division changes to multiplication. What happens with the 2? What happens with the 2? We flip it. Division changes to multiplication. We flip the 2. This is what? 1/2. So if I say 12 divided by 2, 12 divided by 2, we change division to what? We change division to multiplication. We get 12 multiplied by what? The reciprocal, which is what? 1/2. So 12 times 1/2 is 6. Now, what's happening each time? You say dividing by 2. No, what's being multiplied is the question. What's being multiplied? We're multiplying by 1/2. Multiplying by what? 1/2. This is what we call R, or the common ratio. The common ratio R is 1/2. And how do we find it? We take the second number, which is 8, and divide by what? The first number, which is 16, we get 1/2. So what is being multiplied each time? What's being multiplied? 1/2 is being multiplied. Do you see that the values are getting smaller and smaller and smaller and smaller and smaller? Okay? If the values are getting smaller, what happens is as we add forever, we start to get very close to a specific number. Watch this. So I'm going to write this out. Plus 1. Plus, what's next? 1 times what? 1 times 1/2 is what? 1/2. And I tell students, once we get to fraction form, it's easy. Times 1/2 again. Times 1/2 again. 1/2 times 1/2. Do top times top. Bottom times bottom. 1 times 1 is 1. 2 times 2 is 4. We get a 4th. Times 1/2 again. Times 1/2 again. What do we get? 1/8. Times 1/2 again is what? Same thing. Top times top is 1 times 1 is 1. 2 times 8 is 16. Keep doing this. So we get what? Don't forget your addition. Plus, plus, plus. 1 over 16 is what? 1 over 16 times 1/2. Times 1/2 is what? 1 over 32. So let's just go ahead and go in this pattern. You see the pattern. We're doubling the denominator. So plus what? Plus 1 over 64. Plus what? 1 over 128. I'm going to keep adding. Plus what? Plus 1 over 256. Plus 1 over 512. Plus 1 over 1024. Plus what? Plus dot, dot, dot. Is this addition ever going to end? No, this addition goes on for what? Forever. I've just written some more terms. Now the question is, let's start adding and see what we get. Let's start adding and see what we get. Watch. This is pretty interesting. 16 plus 8 is what? 24. Start adding with me. Follow this. 16 plus 8 is 24. Plus 4 is 28. Plus 2 is 30. Plus 1 is what? 31. So these numbers give a sum of what? 31. So let's write 31. Now add 1/2. What's 31 plus 1/2? We get 31 1/2. 31 1/2 plus a 4th. Plus a 4th. See if you can find the pattern here. Plus a 4th is 31 3/4. Plus an 8th. Plus an 8th is 31 7/8. Plus a 16th is 31 15 over 16. Plus a 32nd is 31 and what? 31 over 32. Do you see what's happening? Look at your numerator. Do you see that your numerator is 1 less than your denominator? Okay, watch. Plus a 64th is 31 63 over 64. Plus 1 over 128 is 31 127 over 128. Plus 1 over 256 is what? Can you guess it? Can you guess it? Notice the values are 1 less than the numerator is 1 less than the denominator. So plus 1 over 256 is what? 255 over 256. And then we get 31 and plus 1 over 512 is 511 over 512. Plus 1 over 1024 is 31 and 1023 over 1024. My question is this ever going to get to 32? Is this ever going to get to 32? Notice 31 1/2, 31 3/4, 31 7/8. No, it's never going to get to 32. Look at it. Look at the pattern. Is this a value or is this sum? As we keep adding and adding and adding and adding and adding, are we ever going to get to 32? No, because the fraction will always be just slightly smaller than 1. Let me show you in decimal form. Maybe you can see it now. Watch. 31 1/2 is 31.5. Now I'm going to start estimating when I get further along. 31 3/4 is 31.75. 31 7/8 is 31.875. 31 15/16 is 31.9375, I believe. 6 times, 6 and a 4th. Yeah. So I'm going to start estimating now. I'm going to start estimating. 31 and 0.97. 31, this is 31.99, or let's say 98. 31.98, this is 31, this is 31.99, this is 31.999, this is 31.9999, okay, a little off, but I want you to get the concept. 31.99999, okay, what's happening? Look at this. What's happening is we keep adding what's happening. We're getting closer and closer and closer and closer to what? Closer and closer and closer and closer to 32. I didn't write 31 there. 31.999. So we're getting closer and closer to 32. Are we ever going to stop adding? The plus dot dot dot. Are we ever going to stop adding? No. We're never going to stop adding. So are we forever going to get close to 32? Yes, we're going to forever get close to 32. Will we ever get there? That's the question. Will we ever get there? No. But the whole saying is this: anything you can do, I can do better. So as close as you can get, I can get closer. You say, no, no, no. I can get closer than you, Mr. Thaxton. Okay, so you say, all right, you start thinking, 31.99999999999. You just say this for a long time. 9. Okay, so you say, I'm close. And I say, well, guess what? 31.99999999999999999. I say one more 9 than you, and guess what? I'm closer than you. All I have to do is add what? One more 9 to the end of my string, and I'm closer than you. You say, hold on, I'm going to put 5 million 9s on the end of my string. I say, all right, great, I'm going to put 5,000,001. So I'm always able to get closer than you are. So my question is, will this value forever get close to what? Forever get close to 32. No matter, since we're adding forever, every time we add another 9. Every time we add another number, we put another 9 on the string. Since we're never going to stop adding, what is this thing equal to? This sum is equal to what? 31.9 repeating forever. It's the same question. Is 1 equal to 0.9 repeating forever? I said, coming into today, no. Okay? Who thought of these things? Isaac Newton started thinking about this stuff back in the 1700s. Isaac Newton said, hey, hold on now. Okay, what happens in real life? Okay, what happens in real life? Does the hare ever catch the tortoise? Theoretically, no. But in real life, what happens? The hare passes the tortoise. And question, is my hand theoretically touching this wall? No, because I'm nothing but a bunch of empty space. But Isaac Newton said this. He said, get over it. Get over it. We can push on the wall. We can open the door. I can hear. Is my hand ever touching this pen? No. But can I move the pen, pick it up, touch? Yes. I can move things. Even though I'm nothing but empty space, I can move things. So Isaac Newton said, get over yourself. We're going to call this what? We're going to call this what? 32. Forever getting close, we're going to say that this converges to 32. So today this is equal to 32, and I'm going to show you why this is equal to 32. Why is this equal to 32? Because they decided to define it this way, by this definition. Last definition in this class. Oh, thank you. Gosh, this has been such a long string of definitions. This is the last one, and a very important one to know. Okay, so for the rest of this course, I promise you guys this, the rest of this course will get easier. This is probably the hardest, well, not this, maybe sequences, but sequences and series are pretty much the hardest topic in this class. After this, things start getting easier. Okay, so this is your last definition, but don't forget them. You have to know these for tests and quizzes, but I will not be adding more than just here and there a formula. Okay, so definition of definition of convergent series. All right, now, definition of convergent series says that if the absolute value of r is less than 1 and r is not equal to 0, then the series is convergent. Convergent means getting very close to a value. The series is convergent. Convergent. And sigma n equals 1 to infinity of a sub 1 times r to the n minus 1 power is equal to a sub 1 over 1 minus r. Now, we'll get into what this means in a minute. What I'm saying is, why is this equal to 32 today? This definition comes from calculus. And I want you to write, this definition is saying what? This definition is the definition of a type of limit. What is 32 called? 32 is called a limit. What does limit mean? Limit means what we forever get close to but never actually get there. Do we ever get to 32? No. But as close as you can get, I can always get closer. And if I get closer, you can get closer than me. So we can forever get close to this number, but we will never, ever, ever get there. So will we ever get to the limit? No. But what do we call? The limit is what we will forever get close to but never get there. What is the limit here? The limit is 32. And what is this series saying? This series is saying today we are what? 31.9 repeating is what? Equal to 32. Okay, so this definition is what says this is equal. Okay, so 31.9 repeating was not 32 until I gave you this definition. This definition is borrowed from calculus. In fact, when you study calculus, the whole course rests on what? The whole course rests on limit. Once you understand concept of limit, which is a really simple topic, actually, you know, right now it may look crazy, but calculus is easy. Calculus is easy. Limit is easy. Okay, what's the hard part about calculus? Students always say calculus is so hard. What's the hard part about calculus? Calculus is hard because it's 99.9% algebra. What's hard about calculus? The algebra 2 is hard. 99.9% algebra. That's what's hard about calculus. Students that say calculus is hard, it's not the limit that's hard. What's hard about calculus? It's the algebra. So this is the hardest stuff, guys. Algebra is the hardest stuff out there. Okay, so we've got to get good at algebra in order for calculus to be easy. Okay, so algebra is the key. If calculus is hard, it's because algebra is weak. If calculus is easy, it's because your algebra is strong. Okay, so algebra is the key to making calculus easy. But calculus concept, the whole subject of calculus is to study what thing? The concept of limit. Forever getting close to something, but never getting there. Now, all right, so let's look at this again. Now what I'm going to do is I'm going to write this in sigma notation. Now, sigma, n equals 1. I want you to do this. N equals 1 to 5. N equals 1 to 5 of 16 times 1/2 to the n minus 1. This is what we did yesterday. Now, I told you guys the first value. Remember, this is a sub 1. Underline the 16. It's kind of easy. The problems are really, really easy, guys. Watch this. 16 is a sub 1, and the r value is 1/2. So what's our first value in the sum? Remember, sigma means add. First value is what? 16. And what are we multiplying by to get to the next term? We're multiplying by 1/2. So multiply by 1/2. 16 times 1/2 is what? Well, 16 divided by 2 is 8 times 1 is 8. Multiply by 1/2 again. We get what? 8 divided by 2 is 4 times 1 is 4 times 1/2 is 2 times 1/2 is 1. How many terms are we adding here? We're adding from what? 1 to 5. From 1 to 5. So we add these up. We add these up and we get 24, 28, 30, 31. We get 31. But what's happening today? We're changing this 5 to what? We're changing this 5 to what? To infinity. Infinity and beyond, right? As Buzz Lightyear said. Okay, so we're changing this to what? Infinity. So what does this mean? Are we ever going to stop adding? No. 5 meant we're adding what? The first 5 terms. A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. That's what you guys did for your test. Just the first 5. Now what are we doing? We're adding what? Forever. So 5 becomes what? Infinite. Or we're changing this top value to infinity, forever, the concept of forever. So what does this become? This becomes what? Plus dot dot dot. Okay, so we're adding forever. The question is this going to converge or is this going to diverge? Well, we always figured out. Converge means get close to a number. Converge means get close to a number. So is this converging or getting close to a number? Yeah, we already figured it out. What is it converging to? It's converging to the limit 32. It's getting forever close to 32. So how do we figure this out? This is how easy the problems are, guys. First, you're going to state this. First, you're going to state that the absolute value of r, what does it say in this sentence? Let's figure out what this means. Hold on, before we do this. The absolute value of r is less than 1. What does this mean? So let's write this over here. Let me erase all this off the board. The absolute value of r is less than 1 means what? Okay, we have to understand what this means. Absolute value of r is less than 1 means what? Solve it. We're looking at an absolute value equation. Is this an and statement or an or statement? Hopefully you say this is and why, because we can make an a out of it. This is an and statement. So absolute value of r is less than 1, we write two equations. R is less than 1 and what? And r is greater than its opposite. 1 becomes what? Negative 1. Now, is there anything else to solve? No, but and statements have to be compressed. We put r between two values, smaller value to the left, larger value to the right, smaller value is negative 1, larger value is 1. Remember, your signs always point in what? The same direction. They always point to the left. So notice, if you forget r is less than 1 is right there. R is greater than negative 1. We read this is what? What's our word here? This is between. Okay? So between what? Between negative 1 and 1. Let's put this on the number line. Call this the r-axis. Here's 1. Here's negative 1. And open or closed. Question, open or closed at negative 1? We're open. Open or closed at 1. Hopefully you say open. Now, we're not including negative 1, we're not including 1. What else does it say in the definition? In the definition it says that r is not what? R is not 0. So what else? At here, don't connect these yet. Here's 0. Do we have a value? Is r equal to 0? No, r is not 0. So I want you to put an open circle above 0. So question, is 1 an acceptable r value? No. Is 0 an acceptable r value? No. Is negative 1 an acceptable r value? No. These open circles mean it's not acceptable value, or it's not in the solution. Now, between, connect everything else between. This solid region connecting these open circles represents the acceptable values of r. So where does r have to be? R has to be between 0 and 1, and r has to be between 0 and negative 1. So my question is an r value of 2 acceptable? No. Is an r value of negative 2 acceptable? No. An r value has to be what? Between 0 and 1 or 0 and negative 1. What is this? Here, look at our r value in this statement. The r value is what? 1/2. Put 1/2 on this number line. Where's 1/2? It's right here. Is 1/2 in the acceptable region? Yes. What does this mean? If R is in the acceptable region, then the series is what? Convergent. The series is convergent, meaning that as we add forever, we're going to get closer and closer and closer to a number. Look at this. So what are we going to state? We're going to state that the absolute value, we state this. The absolute value of R, which is what? In this case, it's 1/2. We say that the absolute value of 1/2 is less than 1. Is that true? Yes, this is true. We say, therefore, the series is what? Convergent. I want you to write convergent. This means that we forever get close to the value. This is required on tests and quizzes. So the absolute value of R, absolute value of 1/2 is less than 1. Therefore, the series is what? The series is convergent, meaning that we're going to forever get close to a value. And what do we use? We use this formula to find what it converges to. My question is, do you guys always want to add 16 plus 8 plus 4 plus 2 plus 1 plus, and keep adding until you guess the value? Well, you can do this and guess what it's getting close to, but it's not always obvious. So I'm telling you this, it's easier to use the formula to figure out what it's getting close to. Watch this. The formula says put a sub 1 on top, and what is a sub 1? Let's circle it. What is a sub 1? A sub 1 is 16. You can also circle it here. This is a sub 1. Put a sub 1 of the first term on top, and put your R value on the bottom. So we're going to say this is equal to what? This is equal to a sub 1, which is what? 16 over 1 minus the R value. What's the R value? The R value is 1/2. 1 minus 1/2, 16 over 1 minus 1/2 gives, now we need to convert 1 to an acceptable form of, we need a common denominator. So what is 1? Is 1, question, is 1 7 over 7? Yes. Is 1 8 over 8? Yes. Is 1 9 over 9? Yes. Is 1 163.2 over 163.2? Yes. How many forms of 1 are there? There's infinitely many forms of 1. We need a form of 1 that's going to have a common denominator with 2. So we're going to change the 1 to what? We're going to change the 1 to 2 over 2. Remember, when we add fractions, what matches doesn't change. And we just add the top. So we get what? The 2 does not change. And we do 2 subtract 1, we get a half. Okay, 1/2 and 16 on top. So a 1 minus a half is obvious. We get a half. 16 divided by a half. So 16 divided by a half, old school. We get 16 divided by a half. Old school is 16 divided by a half, written like this. Again, what does division change to? Division changes to what? Multiplication. So we get 16 multiplied by what? We flip the 1/2 and make that what? 2. 16 multiplied by 2 is 32. Look, 32. Look, 32. 32. Okay, so does this formula get the value that the series is converging to? Yes, it finds the limit or the value. So question today, after giving you this definition, is 0.9 repeating equal to 1? Yes. Why? Because I've given you the definition. Who thought of this? Who thought of this definition? Newton did. Okay, in fact, there were people before Newton that were thinking of these ideas. Okay, forever getting close to something, but not actually getting there. Now, let's look at here. Can we skip this step? 16. My question is 16 divided by, here, 16 over 1/2. I want to skip this step. 16 divided by a half is equal to 16 old school divided by a half changes to what? 16 multiplied by the reciprocal what? 2, which is 32. Guys, we want to skip this step. So I want you to be able to do this. 16 divided by a half. Can you skip this step? We don't want to write 16 divided by a half every time. I want you guys to see that this is 16 multiplied by what? 16 multiplied by the reciprocal. Flip the 1/2, which is what? 2. So we get 16 multiplied by 2 or 32. So we're just going to skip this step. Now, let's look at this. I'm going to use some more board space here. All right, erasing all this off. So these problems become actually pretty simple because the formula makes it easy. Okay, so let's look at sigma. I'm going to erase this. Okay, sigma, now we're just getting into solving the problems. Okay, we're on page 708 right now. Okay, page 708, and I'm going to talk about the homework and the homework problem. Sigma, n equals 1 to infinity. What does infinity mean? Infinity means we're adding forever. 1 to infinity of 4 times here. 4 times 1/2 to the n minus 1. Okay, again, we have to find our first value. We underline the 4. What is 4? 4 is a sub 1. That's our first value, so we have what? 4. And what's our r value? R value is what? 1/2. So what are we multiplying by to get to the next term? We're multiplying by a half. 4 times a half is what? 4 times a half is 2. Times a half is what? 2 times a half is 1 times a half. 1 times a half. we get what? 1/2. Times a half again. Once we get the fractions, it's easy. Times a half again. 1 times 1 is 1. 2 times 2 is 4. We get a 4th plus what? An 8th. Okay, what does sigma mean? Sigma means what? Add, so put addition. 4 plus 2 plus 1 plus a half plus a 4th plus an 8th plus ... Now, are we adding forever? Yes. We put the ... because of the infinity. We're adding forever. The question is, does this converge or does this diverge? Well, hopefully you say the absolute value. We start with what? We want to use the formula to find what this thing converges to. We want to use the formula. So look, we're going to do the absolute value of 1/2. Absolute value of 1/2 is what? Absolute value of 1/2 is less than 1. Is this true? We look. Is this in the acceptable region of R? Yes. Okay. Is the absolute value of 1/2 less than 1? Yes. Then the series is what? Convergent. And what does this thing actually add up to or forever get close to? We use the formula. The formula says put what? A sub 1 over 1 minus R. Just put your values where they go to find what this thing gets very close to. So A sub 1, circle it. A sub 1 is 4. You can also circle it here. We put what? 4 over 1 minus R, which is a half. So we're going to say that this is equal to, this series is equal to what? 4 over 1 minus a half. And again, we convert the 1 to an acceptable form of 1, 2 over 2. So we get 2 over 2 minus 1 over 2. This is what? 4 over 2 over 2 minus 1 over 2. What matches doesn't change. We get what? 1/2, because the denominator does not change. 2 minus 1 is 1. 4 divided by half is the same as 4 multiplied by what? Flip it. 4 multiplied by what? Flip the 1/2, we get 2. 4 times 2 is 8. If we add forever, what is this thing going to equal? This thing is going to equal 7.9 repeating forever. And 7.9 repeating forever is the same as what? Today it's the same now as what? 8. Why? Because of this definition. Now, let's do one more. Sigma. Let's use k equals 1. Does that matter whether we use n or k? No. K equals 1 to infinity of 9 times 1/3 to the k minus 1. 9 times 1/3 to the k minus 1. Now, we're going to start by writing out the first few values of the sum. I require that you guys write out the first 4 values of the sum. What's the first value? The first value is what? 9. So write a sub 1 is 9, and the r value is what? R value is 1/3. Our first value is 9, so we have 9. And what are we multiplying by to get to the next number? We're multiplying by 1/3. 9 times 1/3 is what? 9 divided by 3 is 3 times 1 is 3. Now the next one, times 1/3 again. Okay, so times 1/3 again gives what? 3 times 1/3. 3 divided by 3 is 1 times 1 is 1. Times 1/3 again. 1 times 1/3 is easy. 1 times anything is itself, so 1/3. And stop there. I said write the first 4 values. So plus, 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 ... So on the homework, you guys have to write the first 4 values. Now, what do we have here? Well, the plus ... We're adding what? Forever. So the question is, does this have a sum or does this converge to a value? Yes. Why? Because the absolute value of r must be less than 1. Check it out. Is r, what is r here? R is 1/3. We write the absolute value of 1/3 is less than 1. Is this true? Yes. Therefore, if we add forever, this is going to get very close to a number. So we say that this series is what? This series is convergent, meaning that if we add forever, we're getting very close to something. We need to figure out what that is. What do we use to figure out what that is? We use this formula. The formula says put a sub 1 on top and put r on the bottom after the 1 subtract. So we're going to say that this is equal to what? This is equal to a sub 1 over 1 minus r, or this thing forever gets close to this formula. Now, what is a sub 1? A sub 1 for this problem, you can circle it here or circle it here. It's the 9. So we say that this is equal to 9 over 1 subtract what? The r value. R value is what? 1/3. The problems are actually pretty easy. Okay, this formula is pretty simple once you get it. So we're not going to do, we need an acceptable form of 1 that has an identical denominator is 3. So what form of 1 do we want? Well, we want 3 over 3. Okay, so 3 over 3 minus 1 over 3. When we add or subtract, what matches doesn't change. Again, so we get 9 over, the denominator 3 does not change. We add the top. 3 minus 1 is what? 2. So we get 9 over 2/3, and this is the same as 9 multiplied by what? 9 multiplied by the reciprocal what? Reciprocal 3 over 2. Now, 9 times 3 is what? 9 times 3 is 27. Okay, this is again 9 over 1 times 3 over 2. We don't write the over 1. You guys understand the 9 is on top, the 1 is on the bottom. So 9 times 3 is 27, 1 times 2 is 2. So we end up with what? 27 over 2. We convert this to a mixed number. How many times does 2 go into 27? We get what? 2 goes into 27 13 times. And how many are left over? We have 1 left over, 13 and a half. Let's start adding and see if we can guess what this thing is getting close to. I'm going to write some more terms out here. 1/3 plus 1/9 plus 1 over 27 plus ... Okay, so if we add 9 plus 3, what is 9 plus 3? 9 plus 3 is 12, plus 1 is what? 13. So we end up with 13, plus a third is what? 13 and 1/3. Plus a ninth is 13 and 4/9. Plus a 27th is 13 and 13 over 27. Okay, I asked students in class, what is this thing getting close to? Some of them said 14. Okay, some of them said 14. Is this thing forever getting close to 14? No. It's forever getting close to what? 13 and a half. Now, it's not always obvious to see this. This is why I say it's good to use the formula. The formula is easier. Okay? It's not obvious, but a third is less than a half. 4/9 is less than a half. 13 over 27 is less than a half. This thing will forever get close to 13 and a half, or if we add forever, we get what? 13.49 repeating forever. The 4 is not repeating, but the 9 is. 13.49999999 forever. This is approximately what? 13 and a half, or if we forever put 9s on the end of this thing, forever, you cannot comprehend this. We've been putting 9s on the end of this thing since the beginning of time and beyond, and still have not stopped. Okay, the 9s have never, as long as you've been alive, 9s have been being put on the end of this thing. Are we ever going to get to 13 and a half? No. But will we forever get close? Yes. The mind cannot comprehend this. We say that this is converging to 13 and a half. Now, I'm going to erase the definition. Hopefully you have this definition written down so you can refer to it. Okay, so now my question is, okay, convergent means getting close. What does divergent mean? Divergent means it's not getting close. Look, sigma n equals 1 to infinity. I want you to do this one. 5 times 2 to the n minus 1. 5 times 2 to the n minus 1. So the question is, what is our first value? What is our first value? A sub 1. What is a sub 1? A sub 1 is 5. So we have 5, and what is our r value? R value is 2, so what are we multiplying by to get to the next number? Well, we're multiplying by 2. So 5 times 2 is what? 10. Times 2 again is what? 20. Times 2 again is what? 40. Always write out the first 3. Plus, plus, plus. And we're adding what? Forever because of the infinity. So plus dot, dot, dot. Now the question is, we're plus dot, dot, dot. Is this thing getting close to a value? Is this thing getting close to a value? Someone said, well, it's getting close to 1,000. Well, my question is it getting close to 1,000 or is it getting further away from 1,000? Look, it doesn't take long. If we keep going, plus 80, plus 160, plus 320, plus 640, plus dot, dot, dot. Okay, by this time, we're already past 1,000. You add a few numbers of this, 5, 10, 20, 40, 80, 160, 320, 640. It doesn't take long for this thing to add up to more than 1,000. Now, once we pass 1,000, are we getting close to 1,000 or are we getting further away? We're getting further away. Okay, you say it's getting close to 1,000,000. Well, it won't take long. About 20 terms and you'll be past 1,000,000. Okay, so we're going to pass 1,000,000. Are we going to get closer to 1,000,000 or further away? We're getting further away. Forever getting large. This sum is forever getting large. It is not approaching a value. We call this what? We call this divergent. Divergent. There is what? There is no sum. How do you show this? You show this by stating that the absolute value of r. What is r here? The absolute value of r is what? The absolute value of 2. Since the r value is 2. Now don't state less than 1. Don't say less than 1. That's false. Okay, if it were less than 1, then it would be convergent. Okay, we state what's the complete opposite. What is the complete opposite of less than? The complete opposite of less than is what? Greater than or equal to. So on your tests and quizzes, you guys will state greater than or equal to 1. Since the absolute value of 2 is greater than or equal to 1, the series is what? Divergent, meaning that if we add, it just continues to get larger and larger and larger. It is not getting close to a value. We say that there is no sum. Now, it makes sense. Think about it. If your r value is 2, if your number that you're multiplying by is 2, what's happening to the numbers? The numbers are getting what? The numbers are getting larger. If your r value is 1/3, your numbers are getting what? If you're multiplying by 1/3, your numbers are getting what? Smaller. What happens when we add smaller and smaller and smaller and smaller and smaller values? we start to get very close to a specific number. That specific number you have to find using the formula. What happens when we start adding larger and larger and larger and larger values? We are not getting close to something. We are forever getting large. This is called what? Divergent. There is no sum. So the key is this. Look, it makes sense. If we're multiplying by something bigger than 1, the values are getting larger. If we're multiplying by something that is smaller than 1, the values are getting what? Smaller. So it makes sense. If your multiplier r is smaller than 1, your values will get smaller, meaning that you're adding smaller and smaller and smaller and smaller things. This is going to converge to a value. It's like this. I tell students, I'm putting bricks in a pile. I start with 10 bricks. Then on top of that, I only put 5 bricks. I'm cutting it in half. Then I only put 2.5 bricks. Then I only put 1.25 bricks. And then I only put a half a brick and a quarter of a brick. And then a very small piece of a brick. And then I'm putting smaller, so I keep doing this, putting smaller and smaller. Then I only put a piece of sand on the top. And before long, I'm only putting a piece of dust on the top. And before long, I'm only putting something so micro you can't even comprehend. So what's happening? The pile of bricks is not getting larger anymore. You're putting things that are so small, something so small on top, it doesn't even change the pile. Okay, so adding smaller and smaller and smaller things, we are approaching a specific value or specific number. However, adding larger and larger and larger things, this value is just getting larger. Let's look at this. Okay, so problems in your book tonight. Look on page 708 real quick. Page 708 number, for instance, page 708 number 10. We're going to solve 3 and we're done. Page 708 number 10. So I'm just going to put these up here real quick. Page 708 number 10 says what? Sigma k equals 1 to infinity of 5 times 4 to the k minus 1. Sigma k equals 1 to infinity of what? 5 times 4 to the k minus 1. I want you guys to notice something. Are there parentheses here? Notice. You have to identify your r value. Are there parentheses around the 4? No. Are the parentheses necessary? Not at all. Okay, the parentheses aren't even necessary. So do they have to write parentheses around your r value? No, they don't. How do you know that you're looking at your r value? The r value is what sits underneath the exponent. So our r value here is what? 4. Circle your 5 and write a sub 1. Circle your 4 and write r. But I want you to go ahead and insert parentheses. So if the book does not put parentheses, the parentheses are only here for us to be able to see our r value. But I want you guys to know the r value sits underneath k. The parentheses aren't even necessary. Put your r value. Now, before we even start, I want you to tell me, is this going to converge or diverge? What are you multiplying by each time? You're multiplying by what? 4. Is 4 bigger than 1 or is 4 smaller than 1? Hopefully you say this is bigger than 1. Okay, so what's happening? The values are going to get larger and larger. So this is not going to converge. This is going to what? This is going to diverge. So this is divergent. But I want you guys to show why it's divergent. That means write the absolute value of what? The absolute value of 4 is the complete opposite. Don't write less than 1. No, we write the complete opposite is what? Greater than or equal to 1. Therefore, the series is what? Divergent, meaning there is no sum. Now I want you to write out the first 4 values. What's our first value? First value is what? 5. What are we multiplying by to get to the next value? We're multiplying by what? 4. So we multiply by 4. 5 times 4 is what? 20. Times 4 again is what? 80. Times 4 again is what? 320. That's good enough. Plus, 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 and what is this? We're adding forever. So plus what? Dot, dot, dot. And you see that you're adding larger and larger and larger values. This is called divergent. Now, next. Question number 11 in your book. This was question 10. Question 10 on page 708. Now we're looking at question number 11. This says sigma k equals 1 to infinity of negative 2 times 0.5 to the k minus 1. Now, I don't want you to write it like this. I want you to convert everything to fractions. So if you see a decimal, like 0.5, I want you guys to write this as a fraction. What is 0.5? It's 1/2. So go ahead and write this as 1/2. And also, do we need parentheses around both values? No, we don't even need parentheses around either value. I don't want you putting parentheses around the a sub 1. So I want you guys to write the problem down correctly. I want you guys putting parentheses around your r value. R is the number that sits underneath the exponent. And I want you to put no parentheses around the a sub 1 value. So let's underline a sub 1 and put what? A sub 1 above it, put r above the 1/2. Now, my question, is this series going to converge or is it going to diverge? hopefully you see that your multiplier is what? Your multiplier is 1/2, which is a value that is smaller than 1, meaning that this series is going to converge. Why? Because when you multiply by 1/2, your values are going to get smaller and smaller. Adding smaller and smaller and smaller things is going to cause this sum to get very close to a number. Let's figure out what that number is. So I want you guys to write your first value. A sub 1 is what? -2. And what are we multiplying by each time? We're multiplying by 1/2. So let's go ahead. -2 times 1/2 is what? Well, divide. Ignore your negative. 2 divided by 2 is 1 times 1 is 1. Multiply by 1/2 again. Hold on now. This is -2 times 1/2, so this should be what? -1. Now, -1 times 1/2 is -1/2 times 1/2 again, times 1/2 again. 1/2 times -1/2 is what? -1/4. And what are we going to put between this? Put addition, put addition, put addition, plus what? Dot, dot, dot. Now, we're adding what? We're adding forever. We have to use a formula here if it's convergent. Now, we've already established this is convergent. Why? We looked at our R value before we started, but I want you to state this. The absolute value of 1/2 is what? Absolute value of 1/2 is less than 1. Therefore, we have what? Convergent. Go ahead and write this. This gets you 3 out of 10 points for writing this statement. Now use the formula. So the formula says what? The formula says put a sub 1 over 1 minus r. Now, we have both values stated here, so let's go ahead and put it in the right place. So we have what? A sub 1 is, this thing, if we add forever, equals what? -2 over 1 minus 1/2, or it gets very close to this number. Let's figure out what this number is. What form of 1 do we want? We want what? 2 over 2? Okay, 2 over 2 minus 1 over 2 is what? 1/2. So we get -2 divided by 1/2. And remember, this is the same as -2. Here, I'm running out of space. This is the same as what? -2 multiplied by the reciprocal. So flip the 1/2, which is what? 2. -2 times 2 is what? -4. So if we add forever, this thing is going to get very close to what? -4. Okay, so if we add forever, this thing actually equals -3.9 repeating forever, which we're going to consider today to be -4. Okay, so it converges to or gets very close to -4. Last problem. Okay, last problem is number 12, sigma. Number 12 says sigma. This was number 11. Okay, number 12 says sigma k equals 1 to infinity. I also want to say this. I'm going to try to make the videos shorter in length as time goes on. This is probably some of the toughest content of the year, guys. It's very hard to shorten these videos because there's so much information here that I must talk about to get you guys thinking differently. Okay, but hopefully next week the videos will get shorter. I'm hoping to make these videos so that you guys can watch them in a reasonable amount of time. So 3 times what? 3 times 4/5 to the k minus 1 power. 3 times 4/5 to the k minus 1 power. And what are we doing? We're adding forever. Now question, is this going to converge or diverge? You should look at your R value immediately. 4/5. Write this. Is the absolute value of 4/5, the R value, less than 1? Yes, this fraction is less than 1, therefore we're going to have what? Convergent. Now I want you to write the first few values of this sum. The first value is what? A sub 1, which is 3. So write 3. Now we're multiplying by what? We're multiplying by 4/5. Okay, reminding 3 times 4/5. This is 3 over 1 times 4 over 5. Although we don't write over 1, you guys understand that 3 is on top. So we're multiplying 3 times 4 and getting what? 3 times 4 is 12. So we get 12 over 1 times 5 is 5. Now multiply by 4/5 again. Multiply by 4/5 again. 12 times 4. It's easy once you get the fraction. Top times top, bottom times bottom. 12 times 4 is 48. 5 times 5 is 25. Multiply by 4/5 again. I'll help you guys with this one. 48 times 4 is the same as 50 times 4. Subtract 2 times 4. Okay, so we get 192 over 25 times 5. You can figure this one out. What is 5 quarters? 25 cents times 5, or what is 5 quarters? 5 quarters make $1.25. So we get 125. And now what are we doing? Sigma means what? Sigma means add, so we're adding these up. Plus what? Plus dot, dot, dot. Now, do you guys want to add these numbers to try to figure out what this thing is getting close to? No. That can be a nightmare. But instead, what do we use? We use the formula. The formula says that this will get very close to what? A sub 1 over 1 minus r. Now, I will say this. This formula works. When you get to calculus, you will not be able to use this formula until you prove that it actually works. But for right now, I want you guys to just take my word for this, that this formula works. It's either take my word for it or you have to prove that it works. And that's a mess. So I want you guys to just understand this formula will find what this sum gets close to. So a sub 1 over 1 minus r, what is a sub 1? We're going to say this is equal to, what is a sub 1? A sub 1 is 3. So we have 3 over 1 minus what? 1 minus what? 4/5. I think I wrote that down correctly. Yeah. 4/5. And what form of 1 do we want? Well, we want 1 to be the same as what? A common denominator of 5, so we're going to change this to what? 5 over 5. 5 over 5 minus 4 over 5 is what? Well, the denominator does not change. We get 3 over what? Add 3 over 5 minus 4 is 1, and the denominator does not change. 3 over a fifth. So we get 3 over 1/5. 3 over 1/5, and this is the same as what? 3 multiplied by the reciprocal, which is what? 5, and 3 times 5 is 15, and that concludes this lesson. Homework on this section is page 709, numbers 29 through 34 all. Numbers 29 through 34 all. All that you have to do tonight is state whether it is convergent or divergent and use the formula. So if it's convergent, meaning that it gets very close to a number as you add forever, or the r value is less than 1, or the absolute value of r is less than 1, I should say. If it's convergent, use the formula. If it's not convergent, just write divergent. Write the first 4 values and you're done. Okay? All right, great. Good luck on your homework, guys. And hopefully when we look at the stuff that's coming, this course is going to get a lot easier. I promise you guys this. All right, great.